ये लास्ट एंड के नाम तो पहले बोला मेरे को मेरी तो मैं इसको बंद कर दूंगा।
नमस्कार प्रतिभा जी, डॉक्टर भारत, मंजू प्रीति जी।
नमस्कार मैडम। नमस्कार मैडम मंजू, चेयरपर्सन मैडम।
डॉक्टर भारत कैसे हो?
डॉक्टर अनुराधा जी बात कर रहे हैं, एक बार बात करिए आप, फिर मैं उनको प्रॉपर इंट्रोड्यूस कराऊंगा।
हाँ जी, हाँ जी, हाँ जी मैडम अनुराधा कैसे हो आप?
ठीक हूँ, आप सुनाइए।
बस अच्छा लगेगा आज आपको सुन के। तो बहुत सारे हम वैदिक मैथ्स के लेक्चर सुन चुके हैं, बहुत एंजॉय कर रहे हैं हम लोग कि कैसे पुराने उसमें फास्ट वन लाइन कैलकुलेशन होती थी। तो आज आपको सुन के भी अच्छा लगेगा। वेलकम टू आवर यूनिवर्सिटी, आवर डिपार्टमेंट इन दिस ऑनलाइन प्लेटफॉर्म। और हम एक्सपेक्ट करेंगे कि कभी हम यहाँ फिजिकली डिपार्टमेंट में भी मिल पाए।
जरूर।
थैंक यू मैम फॉर एक्सेप्टिंग आवर इनविटेशन एंड स्पेयरिंग योर टाइम।
माय प्लेजर।
डॉक्टर बड़क इंट्रोड्यूस करेंगे इस मैम को, सभी पार्टिसिपेंट्स को।
मैं आपको बता दूं, मैं हरियाणा से ही बिलोंग करती हूँ।
अरे वाह मैम, कौन से डिस्ट्रिक्ट से?
सोनीपत।
अरे मैं भी सोनीपत से हूँ, गोहाना से एक्चुअली। मैम अच्छा लगा आपसे मिलके। तो आपका इंस्टीट्यूशन कौन सा है मैम?
दिल्ली यूनिवर्सिटी में हूँ मैं, डीसीएसी कॉलेज में, दिल्ली कॉलेज ऑफ आर्ट्स एंड कॉमर्स साउथ कैंपस में।
हाँ वो अच्छी बात है मैम, सुनना पड़ा था मैंने आपका सारा सीवी, तो अच्छा लगा आपको देख के। हरियाणा से हो ये और भी अच्छी बात है। तो आइए मैम, कभी आइए यूनिवर्सिटी में हमारे यहाँ, तो मिल के बातें करेंगे तो और अच्छा लगेगा। ओके, थैंक यू मैम। ओवर टू डॉक्टर बड़क।
मैं थोड़ा वेट कर रहा था कि पार्टिसिपेंट आज कुछ कम ही दिख रहे हैं, क्योंकि ये ज्वाइन करने लग रहे हैं। मैं 2-3 मिनट और वेट कर लूं।
चलो तब तक डॉक्टर खुराना से मिलवाएं आपको, हमारे ही ऑफिस में बैठे हैं। लो सर जी, आप बात करो मैडम अनुराधा से।
नमस्कार मैडम।
सर आप भी मैथ्स डिपार्टमेंट में हैं?
जी मैडम।
अच्छा,
वेलकम मैडम।
थैंक यू सो मच सर, थैंक यू।
मैम सर ना हमारे यहाँ वैदिक मैथमेटिक्स पढ़ा रहे हैं, कई सालों से पढ़ा रहे हैं ओपन इलेक्टिव पेपर में। तो सर को बहुत ज्यादा नॉलेज है आपके इस फील्ड की। तो
कई सालों से तो नहीं मैडम, बस 2-3 सालों से ही है। वो भाटिया जी आए थे तो अपना काम अधूरा छोड़ के
तो आप पूरा कर रहे हैं?
तो इन्होंने, मैडम ने मेरी जिम्मेवारी लगा दी।
अच्छी बात है, फिर तो आपको तो सब कुछ आता होगा सर, हम तो शायद बहुत पीछे होंगे।
नहीं, सब कुछ तो मैं नहीं कह सकता, बस थोड़ी बहुत चीजें, थोड़ी बहुत नॉलेज कह सकते हैं कि हम थोड़ा सा फैमिलियर है वैदिक मैथमेटिक्स से। तो चलिए आज आपको सुनने का मौका मिलेगा।
जी,
बेस्ट विशेस मैडम।
थैंक यू सो मच जी।
ओवर टू यू डॉक्टर बड़क।
थैंक यू सर, थैंक यू सर। नमस्कार।
नमस्कार नमस्कार।
मैडम अनुराधा जी नमस्कार।
नमस्कार सर, नमस्कार।
मैडम हमारे डिपार्टमेंट में हम 6 फैकल्टी मेंबर हैं मैडम। उनमें सबसे सीनियर प्रोफेसर मंजू प्रीति हैं, आजकल चेयरपर्सन है। इनकी चेयरपर्सन की सेकंड टर्म है, क्योंकि हमारी यूनिवर्सिटी 2013 में ही बनी थी। उसके बाद प्रोफेसर ममता कामरा हैं, आजकल डीन एकेडमिक अफेयर देख रही हैं हमारी यूनिवर्सिटी का। उसके बाद अभी रिसेंटली 1 साल पहले ज्वाइन किया प्रोफेसर सुरेश कुमार, ये बिट्स पिलानी से आए हैं। फिर हमारे पास हैं खुराना साहब, ये काफी सीनियर फैकल्टी मेंबर है मैडम। ये 1989 से ही, जब हमारा रीजनल सेंटर होता था महर्षि ध्यान यूनिवर्सिटी का, तब से ये कार्यरत हैं। बड़े एक्सीलेंट टीचर हैं सर ये। इसके बाद मेरी बारी आती है मैडम। मैं डॉक्टर महावीर बड़क, मेरी अप्लाइड स्ट्रीम है मैडम। मैं एमडी यूनिवर्सिटी का ही प्रोडक्ट हूँ। उसके साथ ही मेरे साथ डॉक्टर राजेंद्र हैं 6ठे नंबर की फैकल्टी में, और हमारे साथ ना गेस्ट टीचर भी काम करते हैं मैडम 3-4। और ये हमारा अहोभाग्य है मैडम, हम वैदिक मैथमेटिक्स पे एक वर्कशॉप करा पाए। 2-3 साल पहले यहाँ पे प्रोफेसर एसपी बंसल रहे हैं हमारे वाइस चांसलर। उन्होंने वैदिक मैथमेटिक्स पे एक पेपर ही इंट्रोड्यूस करा दिया था एमएससी लेवल पे। उस टाइम पे राकेश भाटिया जी ने कमाल संभाली, एक पेपर पढ़ाया उन्होंने पूरा। अब तक की वर्कशॉप में मैडम हम फर्स्ट डे डॉक्टर श्रीराम चौथाई वाला जी को सुन चुके हैं। नंबर 2 दूसरे दिन 2 लेक्चर राकेश भाटिया जी के रहे। उन्होंने टैबलेट की हेल्प से मैनुअली कैलकुलेशन करके दिखाई हमारे जो डेलीगेट्स हैं उनको। तीसरे दिन दोनों लेक्चर डॉक्टर श्रीराम चौथाईवाला जी के ही रहे। फोर्थ डे डॉक्टर पंकज जी ने कमान संभाली। उन्होंने भी बड़े अपनी निपुणता के साथ सारे ऑडियंस का अच्छे से वैदिक मैथमेटिक्स के साथ पूरा भ्रमण कराया। और आज आपको सुनने का मौका मिलेगा। मैडम, मैं बड़ा लकी समझ रहा हूँ, आपका सीवी पढ़ूंगा मैं सभी ऑडियंस के साथ। आप डॉक्टर अनुराधा गुप्ता एसोसिएट प्रोफेसर हैं दिल्ली कॉलेज ऑफ आर्ट एंड कॉमर्स, यूनिवर्सिटी ऑफ दिल्ली के अंडर, नेताजी नगर साउथ एक्स में। मैडम, आपका प्रोफाइल कमाल का प्रोफाइल है। मैंने सारा एक एक करके पढ़ा, तो उसकी कुछ ब्रीफ मैं आपके सामने रखूंगा। आप मैथमेटिक्स ऑनर्स की डिग्री ले चुके हैं दिल्ली यूनिवर्सिटी से 1986 में। आपने 1988 में एमएससी मैथमेटिक्स हंसराज कॉलेज दिल्ली यूनिवर्सिटी से किया। आपने एमफिल की डिपार्टमेंट ऑफ मैथमेटिक्स यूनिवर्सिटी ऑफ दिल्ली से, और आपने पीएचडी भी डिपार्टमेंट ऑफ मैथमेटिक्स दिल्ली यूनिवर्सिटी से की। मैडम, आप एक सक्सेसफुल प्रोजेक्ट सबमिट कर चुके हैं अप्रैल 2012 में, जिसकी आउटपुट में आपने 2 रिसर्च पेपर पब्लिश किए। और आपके सीवी में मैडम मैं देख रहा हूँ रिसर्च एक्टिविटी भरपूर दौर से मिल रही है। 2021 में आपने 2 रिसर्च पेपर पब्लिश किए, जिनमें से एक है कॉम्प्लेक्स सिमेट्री ऑफ जनरलाइज्ड वेटेड कंपोजिशन ऑपरेटर ऑन फॉक्स स्पेस। मैडम, मीट्रिक स्पेस, बायोमीट्रिक स्पेस, ये तो हमने सुने थे। फॉक्स स्पेस तो मैडम अभी भी हमारे लिए नया ही टॉपिक है। मैडम, ये बहुत रिनाउंड पेपर आपका जर्नल ऑफ मैथमेटिक्स मैथमेटिकल एनालिसिस एंड एप्लीकेशन में पब्लिश है, जिसका काफी हाई इम्पैक्ट फैक्टर है। 2020 में मैडम आपने 8 रिसर्च पेपर पब्लिश किए। इनमें से कुछ हैं जैसे ऑन के कंपोजिशन एंड के हैंकल कंपोजिशन ऑपरेटर ऑन द डेरिवेटिव हार्डी स्पेस। और ये जर्नल आपका बनाक जर्नल ऑफ मैथमेटिकल एनालिसिस, ये भी काफी रिनाउंड जर्नल है। इसमें पेपर छापना अपने आप में एक अचीवमेंट है। मैडम, आप इसके लिए बधाई के पात्र हैं। मैडम, आपने 2019 में भी 12 पेपर पब्लिश किए हैं। लगता है मैडम आप लगातार रिसर्च एक्टिविटी में ज्यादा ही बिजी रहते हो। 2018 में आपने 6 रिसर्च पेपर पब्लिश किए। 2017 में आपने 7 रिसर्च पेपर पब्लिश किए। 2016 में आपने 4 रिसर्च पेपर पब्लिश किए, जिनमें से एक है स्क्यू एन नॉर्मल कंपोजिशन एंड वेटेड कंपोजिशन ऑपरेटर ऑन L2 स्पेस, इंटरनेशनल जर्नल ऑफ प्योर एंड अप्लाइड मैथमेटिक्स, वॉल्यूम 107। इट्स ए गुड। मैडम, आप फिर से बधाई के पात्र हैं। 2015 में मैडम आपने 11 पेपर रिसर्च पब्लिकेशन दिए, और 2014 में मैडम 5 रिसर्च पेपर आपने पब्लिश किए। 2013 में 4 रिसर्च पेपर पब्लिश किए। और इस तरीके से मैडम आप लगातार कंटिन्यूसली एंगेज रही हैं रिसर्च एक्टिविटी में। इस रिसर्च एक्टिविटी को आपने अकेले रिसर्च से ना जोड़ के आपने कॉन्फ्रेंसेस और वर्कशॉप को भी टाइम दिया है। अब तक आपने 20 कॉन्फ्रेंसेस और वर्कशॉप अटेंड कर चुके हो, और उसमें अलग अलग पेपर प्रेजेंट कर चुके हो। आप ट्रेनिंग प्रोग्राम में भी बढ़ चढ़ के हिस्सा लेते हो। मैडम, आपने अब तक 12 ट्रेनिंग प्रोग्राम अलग अलग टाइम पे करवाए हैं। और मैडम आपका सीवी काफी लंबा है मैडम, मैं तो देख पा रहा हूँ। और मैं इतना आपका बायोडाटा अपने ऑडियंस को, कैंडिडेट्स को बता पाया। और आप अपने आप में एक मिसाल हैं। आप और लोगों के लिए मोटिवेशन का काम कर रही है मैडम। लेडीज होने के साथ साथ घर का काम भी होता है, डिपार्टमेंट का भी होता है, रिसर्च एक्टिविटी को भी इतना देख रही है मैडम। मैडम आप बधाई के पात्र हैं और मैडम आपका हमारी यूनिवर्सिटी में आपका स्वागत है, स्वागत है, स्वागत है।
थैंक यू सो मच।
मैडम आप हमारे ऑडियंस के लिए आज 2 लेक्चर लगातार डिलीवर करेंगी। आप चाहें तो बीच में मैडम ब्रेक ले सकती हैं, 5 मिनट 7 मिनट जो भी आपको कंफर्ट लगे। और मैडम बीच बीच में ऑडियंस को आप कहेंगे तो क्वेश्चनरी के लिए मैसेज छोड़ देंगे, हम आपको मैसेज पढ़ के बता देंगे या आप खुद भी पढ़ पाएंगी। किसी भी टाइप की असिस्टेंट हेल्प के लिए जरूरत पड़े मैडम, हम यहीं साथ बैठे हैं बिल्कुल। और मैडम ने जैसे आपसे रिक्वेस्ट की कि जैसे ही कोरोना काल खुल जाएगा हम आपको फिजिकली अपनी यूनिवर्सिटी में बुलाएंगे। थैंक यू मैडम, थैंक यू।
जब आप कहेंगे मैं जरूर आऊंगा। हरियाणा आने मैं कभी नहीं चुकती।
मैडम आप अपने लेक्चर के लिए तैयार हैं मैडम?
हाँ बिल्कुल, आप
जी
कहेंगे।
मैडम, जी मैडम, प्लीज कंटिन्यू मैडम प्लीज।
मैं स्क्रीन शेयर करती हूँ।
जी मैडम।
I hope screen is visible to all of you.
हाँ मैडम अभी
Okay. The topic which I'm going to take today, I can speak in English now.
no problem, you can speak English as well as Hindi according to your comfortness.
Okay, thank you so much. Today's topic is divisibility, and I'm going to deliver 2 lectures. The first lecture is divisibility when the divisor is ending in 1379. This is a very interesting topic. Give me a few seconds. Let me settle down. This is divisibility. When divisors are ending in 1379. See, when the divisors are ending in 2, 4, etc., it is easier to find. But when the divisors are ending in 1379, it is slightly difficult. So for this, we are using oscillation method. There are 2 types of oscillations. First is positive oscillation. Second is negative oscillation. For positive oscillation, we are using Veniculum. We are using ekadikana Pervading. Means one more than the previous one. Whereas for negative oscillation, we are using Ekneun Pervading, meaning one less than the previous one. Positive oscillation is denoted by P, negative oscillation is denoted by Q. Now, for example, if we have, say, 29, we add 1 to it, so this becomes 30. We just remove this 0, so in this case, the positive oscillation is 3. If suppose you have 109, we add 1 to it, this is 110, we just remove it, so positive oscillation is 11. Similarly, if suppose you have 51, you subtract 1, this is 50, so this negative oscillation is 5. Just remove 0, though this is 5. If suppose you have 121, you just remove 1, this is 120, so we remove this, so the negative oscillation is 12. So in this way, we find positive and negative oscillations. Shall I erase this? Okay. See, I'm giving you rule for positive as well as negative oscillation. So you please note down. Obviously, as I told you, then when it is 29, we add 1, then this is 30, and we remove this is positive oscillation. So basically, the numbers are ending in 9. So the first rule is, if the numbers are 9, 19, 29, 39, etc., is all ending in 9, then corresponding to this, if we add 1, this is 10, 20, 30, 40. So in this case, the value of P, it is 1, 2, 3, 4, etc. Now, if the numbers are ending in 3, 13, 23, 33, means all ending in 3. So we have to make this end in 9. So what we do, we multiply all numbers by 3. So this is known as multiplier. So when you multiply by 3, what happens? It becomes 9. This is 39, then 69, then 99, and so on. When you add 1 and you want to find out the positive oscillation, what is the positive oscillation? 9 plus 1 is 10. When you remove 0, it is 1. 39 plus 1 is 40. When you remove 0, this is 4. Then 69 plus 1 is 70. So oscillation is 7. 99 plus 1 is 100. You remove 0, so oscillation is 10, and so on. Similarly, if the numbers are 7, 17, 27, 37, etc. Madam Pruthi, students are asking whether you have YouTube link or not.
Yes, ma'am, I'm sending in the chat box.
Okay. So, if this is 7, 17, 27, 37, so how do we make it ending in 9? It means the multiplier should be 7. You multiply all the numbers by 7. 7 sevens are 49. Okay, so these all ending in 7. So the numbers are 7 sevens are 49. So this is 49. This becomes 120, 119. Then this is 189. This becomes 259, and so on. So corresponding to this, the positive oscillations are 49 plus 1 is 50. It is 5. 119 plus 1 is 120. It is 12. 189 plus 1 is 190. So oscillation is 19. 259 plus 1 is 260. So oscillation is 26, and so on. Next rule. If the numbers are ending in 1, the numbers are 1, 11, 21, 31, etc. So how do we make these ending in 9? So we multiply all with 9. So these numbers becomes 9, 99, 189, 279, etc. So what is the positive oscillation for this? 9 plus 1 is 10. It is 1. 99 plus 1 is 100. So this is 10. 189 plus 1 is 190. So oscillation is 19. 279 plus 1 is 280. So oscillation 28, and so on. So you please note down, then I will erase and tell you about negative oscillation. Shall I erase this? So rules for negative oscillation. So first is, if the numbers are 1, 11, 21, 31, 41, we do not consider 1, because if we consider 1, then the oscillation is 0, has no meaning. 41, 51, etc., all ending in 1. So in this case, we subtract 1 from each, right? So the numbers, the negative oscillation corresponding to this is 10. So it is 1, 20 minus 1 is 20, 21 minus 1 is 20. So this is 2, 3, 4, 5, etc. If suppose the numbers are 7, 17, these are the divisors. 37, 47, 57, all ending in 7. So we want all these to end in 1, because for negative oscillation, the number should be of the form 31, 51, 101, like this. So all numbers should be ending in 1 when we want to find out the negative oscillation. So when will this end in 1? So what is the multiplier here? This is 3. 3 sevens are 21. Okay. So in this case, the numbers become, this is 21, 51, then 81, then 111. Okay, and then this is 141, 171, and so on. So in this case, what is the negative oscillation? It is 2, 5, 8, 11, 14, 17, and so on. The next is, if the numbers are 3, 13, 23, 33, 43, etc. So what is the multiplier? Because all of them should end in 1. So the multiplier is 7, 7 3s are 21, etc. So the numbers are, this is 21, 91, 7 se kare na. So 161, this is 231, 301, etc. So what about the oscillation in this case? 2, 9, 16, 23, 30, etc. So if the numbers are 9, 19, 29, 39, 49, etc., but this should end in 9. So we need to multiply by 9. So it means these numbers are 9 9s are 81, 171, then 261, 351, 441. So what about the negative oscillation? 8, 17, 26, 35, 44. Now, after seeing these rules, you can observe one thing, that corresponding to every divisor, you can see all ending in 1739, we can have positive oscillation as well as negative oscillation, right? If just observe rules given for positive oscillation as well as negative oscillation. So one natural question comes in our mind, that is there a relationship between positive oscillation, negative oscillation, and divisor? Yes, of course. We have this rule that positive oscillation plus negative oscillation is equal to the divisor, is equal to the divider. Okay, so I will prove it. Divisor लिखते हैं इसको. So I will prove this now. Shall I erase this? So let us find out the relationship between positive oscillation, negative oscillation, and divisor. So we make a table. Here we write number, means the divisor. Here we write the multiplier of for P. Then here we write the multiple of Q. then the value of positive oscillation, the value of negative oscillation, and its total. I'm giving few examples and you can make out that yes, there is a relationship. If the number is 1, right? So what is the multiplier for P? Because P should end, for P, it should end in 9. So the multiplier is 9. The number becomes 9, 9 plus 1 is 10, and the positive oscillation is 1. And this is already 1. So for negative oscillation, number should end in 1. This is already 1. So what is the oscillation here? 0. And you can say 1 plus 0 is 1. This is matching with this divisor. If you consider 3, it should end in 9. So multiplier is 3. 3 3s are 9. 9 plus 1 is 10. So again, the multiplier, this oscillation is 1. For Q, it should end in 1. Okay. So what is the multiplier? 7. 7 3s are 21. So 21 minus 1 is 2. So the negative oscillation is 2. You can see 2 plus 1 is 3. So you can see P plus Q is the divisor. Next is 7. P should end in 9. So for 7, it is the multiplier is 7. 7 7s are 49. 49 plus 1. Okay, let me repeat. Okay. P for positive oscillation, the number should end in 9. For negative oscillation, it should end in 1. Okay. So let us come to the first. The first number is 1. It should end in 9. 9 को end कब करेगा? मैंने अभी रूल बताया आपको. रूल में अगर लिस्ट में देखो पॉजिटिव ऑस्किलेशन में जब 1 11 हो तो हम 9 होता है उसका मल्टीप्लायर, तो हमने इसको 9 से मल्टीप्लाई किया. 9 से मल्टीप्लाई करें, 9 1s are 9. इसमें 1 ऐड करोगे तो 10. जस्ट रिमूव 1. So this 1 is the positive oscillation. तो ये 1 आपका आ गया positive oscillation. This is already Q should end in 1. ये already 1 है. तो 1 minus 1 is 0. तो इसका negative oscillation 0 हो गया. So 1 plus 0 is 1. Similarly, 3. For 3, it should end in 9. So 9 कब बनेगा? जब 3 से multiply करोगे. 3 3s are 9. Again, 9 plus 1 is 10. So positive oscillation is 1. And for Q, it should end in 1. 1 पे end कब करेगा? जब 7 से multiply करोगे. 7 3s are 21. So 21 minus 1 is 20. Q में हम एक minus करते हैं क्योंकि it is 1 less than the previous one. और P में हम एक add करते हैं. अभी example दूंगी ना आपको clear हो जाएंगी. I am just giving the background. What are oscillation and what is the relationship? So 20 you just remove. So 2 is the negative oscillation. ये मैंने 2 लिखा. 2 plus 1 is 3. So similarly 7, 49, 9 पे कब end करेगा? So 49 होगा. 49 plus 1 is 50, right? So positive oscillation is 5. 7 है. So it should be multiplied. It should end in 1. तो क्या करें multiply इसमें? 7 end कर रहा है. 3. 7 3s are 21. So this is coming out to be 2. 5 plus 2 is 7. Similarly, if you consider any other number, say 11. 11 ले लो. 11 should end in 9. 9 is the multiplier. 11 9s are 99. 99 plus 1 is 100. So positive oscillation is 10. Similarly, this is already ending in 1. So its multiplier is 1. 11 into 1 is 11. 11 minus 1 is 10. So it is 1. So you can say 10 plus 1 is 11. You consider any number, right? Any divisor which are ending in 1, 3, 7, 9. For example, if you consider 19. Okay. 19 को किससे multiply करें? ये already 9 पे end कर रहा है. तो 19 plus 1 is 20. So it is 2. Okay. This is 1. Multiplier is 1. So it should end in 1. So what should be the multiplier here? 19. This should be 9. तभी end करेगा. And it is going to be 171. 171 means 17. So 17 plus 2 is 19. So it keeps on going. You can do this. So what is the relationship? That P plus Q is equal to the divisor. From here, from this table, we can make out. So this is the relation. Now let us solve the questions based on it. Shall I erase this? I hope this is clear. If you have any doubt at any point of time, you please ask me. Now, for example, you want to check whether 199694, it is divisible by 29, right? So this divisor is 29. It is ending in 9. So 29 plus 1 is 30. We just remove 0. So here the value of P is 3. So what we do, we consider this 199694. This is, this is the units place. We just drop this unit place and we write 19969 and we add, because this is the positive oscillation, we add, multiply this 4 with this 3. 4 3s are 12. You just add 9 plus 2 is 1, 6 plus 1, 7 is 8, then 9, 9, 1. Again, you drop this units place 1. So you have 1998. Multiply this 1 with this 3. So this is 4. So what you are getting? 8 plus 4 is 12, 0, 0, 2. Okay. So you just drop this. So you have 200. 200 plus 2 into 3 is 6. This is 206. Again, you drop this. So it is 20 plus 6 3s are. I have made some mistake. One 9969 plus 12. Add 3 where? Just a minute. I will solve this. Four 3s are 12. Oh, this is 12 and this is 1 3s are, sorry, yeah, mistaken. So this is 1, we are dropping 1 into 3 is 3. This is the mistake. So 8 plus 3 is 11, 0, 0, 2. So drop this units place. This is 200 plus 1 into 3 is again 3. This is 203. Just drop it. So this is 20 plus 9, which is 29. So this 29 is matching with this 29, the divisor. Okay, we stop. So how do we write the answer? We write this units place in the reverse order. So it is 9, 3, 1, 1, 4. Now, we will take the complement of it, means Veniculum, all from 9, last from 10. सबको बाकियों को 9 से subtract करना है, last को 10 से. This is Veniculum. I hope you know this. 10 minus 4 is 6, 9 minus 1 is 8, 9 minus 1 is 8, 9 minus 3 is 6 and 0. So this is your quotient. So this number is divisible when you are getting the same number in the last or you are getting 0, then we say the number is divisible, and in this way we find the quotient. I hope this is clear. I will give you so many examples. You will be an expert of it. Shall I erase this? Somebody has asked, Ruti madam, एक बार पढ़ना, किसने कुछ लिखा था बीच में? Now, for example, you want to check whether this 46023, this is divisible by 23. Now you can see this 23 is neither ending in 1 nor ending in 9. So we multiply 23 by 3. 69. 69 plus 1 is 70. We just drop this. So positive oscillation is 7. Again come to this. This is 46023. We just drop this units place. So we have 4602. Multiply this 3 with this 7. 7 3s are 21. So what are you getting? 2 plus 1 is 3. This is 2, 6, 4. Again you drop this 3. So 462 plus 7 3s are 21. So this is 3, 6 plus 2, 8, and 4. Drop this 3. So 48 plus 7 3s are 21. So what are you getting? 69. And this is matching with the 69. Okay, we stop. Now we write its complement. It's a quotient. So quotient would be right in the reverse order. 9, 3, 3, 3. 9, 3, 3, 3. And take its complement. When you take its complement, it is coming out to be 10 minus 3 is 7. 9 minus 3 is 6. 9 minus 3 is 6. But this is not the quotient. What we do, since we had multiplied this by 3, so we have to multiply with the same number. So the quotient is going to be 3 7s are 21, 3 6 are 18 plus 2, 20, 3 6 are 20. So 2001, this is the quotient when you divide 46023 by 23. Any doubt? Shall I erase this? I'm giving you one question. You just write. This is 91992134. You divide by 299. Just try this. Then tell me the answer. It is 299 plus 1. It is 300. So oscillation will be 30. Yes, students, are you trying this? Okay, just tell me the answer. Okay, try, no problems. Quotient will come out to be 307666. This is the answer when you divide this number by 299. Very good. Rhythm, well done. Any other? Good. Formal, very good. Yes. So many of you have got the answer. Let us move to the negative oscillation. If suppose you have that you divide, one more thing, when it is not divisible, then how do we identify? First, if suppose you have divide 3, 1, 5, yes, it means you have understood the concept. Thank you so much. So if you divide by 19, so 19 plus 1, it is 20. So positive oscillation is 2. So we drop the units place. This is 3158 and we multiply 3 with this 2. Now this is plus 6. This is 8, 6, 14, 6, 3, 1. Again we drop units place. 3, 1, 6. 4 2s are 8. So this is 324. We drop this units place. This is 32 plus 4 to the 8. So this is 40, right? We drop this. So it is 4 plus 0. This is 4. See, this number is neither ending in the divisor or nor in 0. So therefore, what we say that this number is not divisible by 19. Not divisible. So in this way, we conclude. If in the end you are not getting the divisor or 0, then we say the number is not divisible. Okay. Shall I erase this? Yes, Misha, okay. This answer is correct. Okay, let us come to this negative oscillation. If suppose you have, let us take the simple one. Check whether this number is divisible by 31. So we have 31 minus 1 is 30. In this case, we have ek neun purvain, means we subtract 1 from the previous one. You just remove 0. So negative oscillation is 3. Negative means that we have a minus sign. Okay, so we drop this units place. We have 4, 4, 3 and multiply this units place with this and subtract. In this case, you need to subtract. So this is minus 9. So it means this is 432. Again, you drop this. So you have 43 minus, what is this for 143 beta? 43 minus 2 3s are 6. So this is 27. So 27, 434. Oh, sorry. Yes, 434. So 43. This is 12. Minus, drop this. So minus 4 3s are 12. So you are getting this to be 31. And you can see 31 is matching with this. So we write the quotient. Here in this case, the quotient is 1, 4, and 3, the units place. In this case, we do not take the complement. In negative oscillation, we do not take the complement, and this is the quotient. इसको मैं quotient लिख देती हूँ, क्यों उसको लिखा हुआ है ना? So this is the quotient. 143, 1, 4, and 3. Just take the units place which we have dropped. Now, for example, if we have that divide 1, 3, 4, 6, 4, check whether it is divisible by 17 or not. See, this is ending in 17, not ending in 1. I mean 7, not ending in 1. So we multiply this by 3. 17 3s are 51. We subtract 1. So this is 50. We drop it. So your Q is 5. Again, we drop the units place. 1, 3, 4, 6 minus 4 5s are 20. So what you are getting? 1, 3, 2, 6. Again, drop the units place. 132 minus 6 5s are 30. So what you are getting? 102. Again, drop the units place. 10 plus, I have made some mistake. 6, 4, 2. Tik to kiya. What is 24? Huh. 102 minus 5 2s are 10. So you are getting 0. So in this case, you can see that you are getting 0. So therefore, it is divisible. Okay. So how do we write the answer? The answer will be 264. 0. It is, answer is 0, 2, 6, 4. But this is not the answer because we had multiplied by 3. So we need to multiply by 3. So what is the quotient in this case? The same number you have to use for which you had multiplied. So this is 3 4s are 12. 3 6 are 18 plus 1, 19. So 792, this is the quotient when you divide this number by 7. Okay, I hope this is clear. Shall I erase this? So you people are fast learner, I must say. So if suppose you have 4288143. When you divide it by 2001, what happens? See, 2001 minus 1, this is 2000. You just drop this. So what is Q in this case? This is 200. So drop the units place. It is 422814. And multiply this 3 with this 200. So what are you getting? Minus 600. So this is coming out to be 418 minus 6 is 2842. Drop this units place. So you have 42821 minus 4 into 2. It is 800. So what you are getting? This is 42021. Again drop this units place. So it is 4202 minus 200. So what we are getting? This is 4102. Again drop this 2. So you have 400 minus 410 2143. Okay, this is 00. So this is 400 minus 400. Again, we are getting 0. So it means, yes, it is divisible. So let us write the quotient. The quotient in this case is going to be 02143. This is the quotient. Yes. Right. Now you just try one questions, then we will move forward. Check this number that 23075, it is divisible by 71. You please check whether it is divisible by 71 or not. So you can see that this method is so easy. You can easily check the divisibility when the numbers are ending 179. Yes, very good. Rhythm is very quick to answer. Yes, good, good. Now, there is a common method also to find the divisibility by 7, 11, 13. You just see common method to check the divisibility. By 7, 11, 13. When the numbers are ending in 7, 1, and 3. Okay. See, if you just multiply 7, 11, and 13, what you are getting? 1001. If you subtract 1, it is 1000. Obviously, it will have negative oscillation and it is going to be 100. But instead of doing this, what we do? There is a very interesting method. See, if you have a number 8, and you can see there are 3 zeros. Okay, there are 3 zeros here. So what we do, that we have to make group of, if suppose you want to check this number is divisible by 13. What we do, we make group of 3s. Why group of 3? Because we are getting the multiplier of 3 with 3 zeros. That is why we are making group of 3. If suppose you are getting here 100, then you make group of 2. And if you are getting 10, then you have one number. Okay, so in this way we apply this method. So here we make group of 3s. So this is, and starting from right to left. And alternatively, we subtract, add and subtract. Means first group positive, next group negative, then positive, then negative. So here what would we have? 502 minus 8. So when you calculate, you are getting this to be, you are subtracting. So 494. And you know 494, it is divisible by 13. So for example, the second number is, say, check 164703. Is it divisible by 77? So what we make? We make group of 3s, first group, second group. And we start from right. First group is this, 703 minus 164. This is coming out to be 13 minus 4 is 9. 6 is 3, 5. Okay, 539. 539 is nothing but, this is nothing but 77 into 7. So yes, this number is divisible by 77. See, this is also interesting method. Similarly, if suppose you have that 286143, is it divisible by 143? Is it divisible by 143? Yes, we make the group of threes. So it is 143 minus 286. So what you are getting? This is minus 3, 4, 143. So yes, 143 is divisible by 143. Yes, it is divisible by 143. Okay. If suppose you have a larger number, for example, you have 52488 you just check whether it is divisible by 1001. Okay. So it means all the numbers, whether it is 7, 11, 13 or 1001, or the multiplier 77, okay, or these two, multiplication of these two or these two. From all these numbers, we can check using this method that you make group of 3 and subtract alternatively. So here group of 3, first group, second group and third. So what we have, 436 minus 488 plus 52. Okay, so we add first these two numbers, 436 plus 52, 6 plus 2, 458, 488 minus 488, this is 0. So whenever we are getting 0, yes, this number is divisible by, yes, it is divisible by this. Okay. Similarly, suppose you have 1798888, is it divisible by 7? So again, we make group of 3, 3, 3 and this. So it is 888 minus 179 plus 1. So basically this is 889 minus 179. So you are getting this to be, how much is this? Sorry, 17985. So we have, this is 888 minus 798 plus 1. So this is 889 minus 798. Right? So you are getting this to be 9 minus 8, 1, 9, 91. Right? 91, it is not divisible by 7. So it is not divisible. So in this way, we make out. Okay. Shall I erase? I hope this is clear. If suppose you want to check the divisibility, by 333, 333, 3333, etc. Okay. So in this case, we always multiply the numbers by 3 because we want 9 or 1 or by 7. When you multiply by 3, what you are getting? 9, 99, 999 and so on. So here the positive oscillation would be, here in this case, P would be what? This is 1, this is 10, then this is 100 and so on. So here we have positive oscillation. So in this case, we do not use minus sign. And you know, when we want to check the divisibility by 3, what we do? We add all the numbers. So for example, you have that 135831. You find out the single digit sum or बीजांक जिसको आप कहते हैं हिंदी में बीजांक और single digit sum or cross digit sum. These are different names for this. This is single digit sum. बीजांक or single digit sum or cross digit sum, all are same. These are used to check the answers. So what we do, we just add all the digits, 8 plus 3 plus 1. And you can see that you just cross the sum of 9s. 8 plus 1 is 9, 5 plus 3, 8 plus 1 is 9, this is 3. So it is divisible by 3. Or you just add all the digits. 3 plus 1, 4, 9 plus 4, 12, 12 plus 8. This is 21 aega, 21, the sum is 21. And 2 plus 1 is again 3. So 3 again, so this is 3, single digit sum. So it is divisible. But what happens to 33? Suppose you have this check 3, 3, 2, 2, 4, 1, 3, 6, it is divisible by 33. See, here we have 2 digits, right? So what we do, that we make group of 2s, and then we add 36 plus 22 plus 41 plus 36. So what we are getting, plus 36. You just add 6 plus 1, 7 to 9 plus 6, 15. 6 plus 2, 8. 9 plus 6 is 15. 4 3 is 7, 9, 3, 12, and 14. And when you add it, again you have to make group of 2s. 45 plus 1. 45 plus 1, this is 46. So it means this is not divisible. मैंने कोई गड़बड़ की है ना? 33 था ये, मैंने 2 बार 36 कैसे लिखा? Yes, तभी गड़बड़ आ गई है. 36 plus 33 है ये. This is 33. Again you check the sum. 6 plus 1, 7 to 9 plus 3, 12. 4 plus 3, 7 to 9 plus 3, 12 plus 13, 32. Yes. So this is 1, this is this. So 32 plus 1 is 33. So here 33 is divisible. Yes, it is divisible. Now similarly, if you, suppose you have a larger number. If suppose you want to check that 1, 2, 3, 2, 1, 3, 8, 1, 1, 1, 8, 5, is it divisible by 333? Now, since we have 3 digits here, we make group of 3s. 1, then second group, then third group, and fourth group, and we add. So normally we start with the right. तो उसमें mistake नहीं होती है. ये तो मेरी last time mistake हो गई थी, देखो. ये 811 है. 185 plus 811 plus 213 plus 123. Just add. You are getting 336 plus 7 plus 5, 12. 2 plus 1, 3. Yes, 1332. So again, you make group of 3. So this is 332 plus 1, which is 333. So therefore, this is divisible by this. So I think this is very easy to find. Okay. So I think I can stop, and in the next session, I will take the divisibility by Vajant, Veniculum, etc. Over to you, Pruti madam. Can we have a break for 5 minutes? Yes, Manju Pruti madam. Shall I continue with the other lecture or? Yes, Parag sir. Up. We can continue. Okay, no problems. See, this is divisibility. When you divide a larger number with another larger number, we adopt the long division method. Okay. So this is basically division by Dhwajank or Veniculum. Okay. So before I start this, I want to tell you about the Rekhank. Now, what is this Rekhank? In mathematics, when you write a positive number, you write like this. But when you write a negative number, we put this hyphen before the number. So this is negative of 3 or minus 3. But in Vedic mathematics, this is written as 3 bar. Bar means it is a negative number, right? But if suppose you write minus of 87, then this can be written as 8 bar, 7 bar. If suppose you have that you want to know the veniculum, bar or veniculum, but if you want to find out the veniculum or the deficiency, for example, I have 7, I can write this to be 10 minus 3, which is same as 10 plus 3 bar, which is same as 1 3 bar. It means 7 is same as 1 3 bar. If suppose you have 88, 88 can be written as 100 minus 12, which is same as 100 plus 12 bar or 1 bar 2 bar, which is 112. So it means this is 88 is same as 1 bar 2 bar. This is known as veniculum. You already know this is veniculum. But directly, how do we find the veniculum? And if you have veniculum, then how do we convert the normal number? This is a task now. Otherwise, you think, what is the nearest base? You know the base in Vedic mathematics. These are 10, 100, 1000, etc. Powers of 10. So when you think like this, then it is difficult. So how do we find it directly? So for example, if you have a number, say 3897, you want to find out the veniculum of this number. So what we do, that we subtract all from 9 and last from 10. So 10 minus 7 is 3, 9 minus 9 is 0, 9 minus 8 is 1, and we add 1 to this number. The most significant number, 3 plus 1 is 4. So this is, and we put a bar on this. So this is the veniculum of this number. You can check from here, this is 13 bar. Okay, so we subtract with bar number all from 9, last from 10. So 10 minus 3 is 7. 7 का निकालना आपको 7 का. So this can be written as 07. 10 minus 7 is 3 and we add 1 to this. So you can see this veniculum of 7 is 1 3 bar. Similarly, if you take 88, so we have, you just add 0 here. 10 minus 8 is 2. 9 minus 8 is 1 and we add 1 to this. This is 1. So you have this. So the number in which you are adding 1, it is without bar. Okay, this number is always without bar. If 4 nahi hoga. This is 4, 1 bar, 0 bar, 3 bar. Similarly, if you have a larger number, for example, you say that 538, find the veniculum of this number. So what we do, all from 9, last from 10 and add 1 to the most significant. So we have 10 minus 8 is 2, 9 minus 3 is 6, 9 minus 5 is 4, 9 minus 7 is 2, 9 minus 9 is 0, and add 1 to this. This is 5. So this is the veniculum of this number. Now we can find veniculum also in parts. So what is the benefit of finding veniculum when we use the when we perform division? The use is that whenever we have a large number, means more than or equal to 5, the digit is more than or equal to 5, we can easily find out the veniculum because it makes the calculation simpler. So for example, if you have a number 1598 2372768, for example, this, you can see these digits are more than or equal to 5, these digits. So what we do, we divide this in 2 parts. We find veniculum of the right hand digit separately and left separately. So what we do, This is 10 minus 8 is 2. 9 minus 6 is 3. 9 minus 7 is 2. 9 minus 3 is, this is less than 5. So we add 1 to this. This is 4 and 2 as it is because this is less than 5. Now come to this. 10 minus 8 is 2. 9 minus 9 is 0. 9 minus 5 is 4. And we add 1 to this. This is 2. So in this way, we can find out the Veniculum in parts of a single, a number. So we can divide it in parts. You can all even divide in 3 parts, 4 parts, etc. But the next task is, if a Veniculum number is given, how do we convert it? Okay. If suppose this number is there, this number, I want to convert it into the normal number, this number. So how do we do? Again, we have all from 9, last from 10, and we subtract 1 from the most significant. You can see 10 minus 2 is 8, 9 minus 6 is 3, 9 minus 4 is 5, 9 minus 2 is 7, 9 minus 0 is 9, and we subtract 1 from it. So in this way, we can convert a Veniculum number into the normal number. I hope this is clear. Shall I erase this? See, when you divide any number with another number, it has 4 parts: dividend, divisor, quotient, and remainder. And remainder. Okay. So when you have the normal method, what we do? We write here dividend. We divide it with the divisor. Here we write divisor. Here we get quotient. And then in the last here, we get this remainder. Whereas this is the normal method, conventional method. Whereas in Vedic maths, we write here the dividend, and here we write the divisor, and here we write the quotient, and here we write the remainder. This is the way of writing. Okay, so first we do Dvajang method. Now, for example, if you have divide 2743 by 3. I am taking a very simple example. So in the normal method, first I am performing this with the normal method and then with the this Vedic method. When you divide, so you have 3 9s are 27. When you bring this down, 3 1s are 3, then 1 3, 3 4s are 12. So what is this? 9 14 is the quotient. This is remainder. But when you perform using Vedic math, this is this. You want to divide by 3. So straight away what we do? 3 9s are 27. And here also we write the remainder. Remainder is 0 when you, so remainder is 0. When you divide 0 4 by 3, 3 1s are 3. Remainder is 1. This is 13. So 3 4s are 12. So remainder is 1. So here we write remainder 1. So this is quotient and this is remainder. So this is the way of writing in case of Vedic mathematics. Shall I erase this? So this is basically, this behaves just like a dwaj. So that's why it is known as dwaja. Now suppose you have divide 87653 by 9. So 9 9s are 81. 81, 9 9s are. So 6 is the remainder. So 6 is 6 is the 6 is left. So 66. So when you divide 66, 9 7s are 63. 66 minus 63 is 3. So 35. 35 when you divide. So 9 3s are 27. 3s are 27. What is left? 8. 83. So 9 9s are 81. So what is the remainder? 2. So this is your quotient and this is your remainder. So in this way we find out. But see, if this number is very large, then obviously the division is really difficult. So this method won't work in that case. Okay. So what we do? For that, we use Veniculum method. So let us move to the Veniculum method. This Veniculum method is interesting because it gives us so many shortcuts. Now, for example, you have, I'm taking first simple example, that this is divide 10205 by 88. So we write here 10205 and we want to divide by 88. We take its Veniculum, means all from 9, last from 10. So this number is near 100, or you divide it, subtract it from 100. So 100 minus 88 is 12. So this 12, this is known as modified divisor. This is known as modified divisor. So what we do, we have 2 digits in the modified divisor. So we put a slash here, starting from counting the digits from right to left. So this is first digit, this is second digit. So we put a slash for the remainder. So what we do, the first number as it is, whatever is this number, we put this as it is. Then we multiply this 1 with this 12, the modified divisor. So we write here 12. So again, 0 plus 1 is 1. We multiply this 1 with the divisor. So this is 1 plus 2, 12. 1 into 12 is 12. Then 2 plus 2 plus 1, it is 5. And then we put a slash because their number is over. Now we multiply this 5 with this 12. But you do not write, please, 12 into 5 is 60. No, this is wrong. It is 12 into 5. 5 2s are 10 and 5 1s are 5. In this way we write. So we have 5 1s are 5, 5 2s are 10. Now this is the last digit we have reached. We stop. So here we have 5 plus 2 is 7. 10 plus 5 is 15, right? 15. But this number should have 2 digits because we have 2 digits only. So we add 1 to this. So this is 85. So we have, this is your quotient and this is your remainder. I hope this is clear. I will take so many examples. It will be more clear. Let me repeat. Let me solve it again so that it would be more clear. Okay. You have divide 10205 by 88. This was the question. So we write here 10205. Divide by 88. 88, it is all from 9, last from 10. So you subtract this from 9 and 10 minus 8 is 2 and 9 minus 8 is 1. This 12, this is known as modified divisor. Modified divisor. Or in short, we write this to be MD. This is your MD. Okay. So we write this MD here 12. Now this has 2 digits 2. So starting from right to left, we count 5 1 digits 0 2 and we put a slash. This gives us the remainder. The next is first number, whatever here it is, we write this in the quotient part. First number जो भी है, 1 है तो 1, 2 है तो 2, 6 है तो 2. First number को हम as it is लिखते हैं. फिर इस नंबर को जो भी नया क्वेश्चन आता है इसको हम इससे मल्टीप्लाई करते जाते हैं. 12 into 1 is 12, and we write in the, under next. Now 0 plus 1 is 1. We write here. Again, we multiply this 1 with this 12. So it is 1 into 2 is 12. So we have 12. This is 2 plus 1, 5. We write here 5 and put a slash. क्योंकि अब slash आ गया, अब slash लगाना है. अब इस 5 को आपको हर digit से multiply करना separately. So 5 ones are 5, 5 twos are 10. Now last digit तक पहुंच गए तो we stop. So 5 plus 2 is 7, 10 plus 5 is 15. We write like this. पर इसके पास तो 2 ही digit थे ना remainder में, तो हमें 2 ही चाहिए, तो इस 1 को हम इसमें add कर देते हैं. So this is 5, 7 plus 8, 1 is 8. This 1 behaves just like a carryover. So this is your quotient and this is your remainder. I hope this is clear now. Okay. Let us move to the next question. We बहुत सारे क्वेश्चन करेंगे, आपको इसकी प्रैक्टिस हो जाएगी, don't you worry. Now, for example, if you have that you divide 1, 2, I am taking simpler and then we will take larger. Check, this is divisible by 89. So we have 1, 2, 2, 4, 89. You want to ask some question or you want me to give question? I will first explain all the questions of different type, then give you a question. See, 1, 2, 2, 4. When you divide, स्लैश कितने, स्लैश उतने ही डिजिट के पास होता है जितने डिजिट में मॉडिफाइड डिवाइजर. मान लो 89 है, 89 में को आप ऑल फ्रॉम 9 करोगे, 100 में सब्ट्रैक्ट करोगे, आपका क्या आएगा 11. 11 में 2 डिजिट है, तो राइट से आप स्टार्ट करो. 4 1 डिजिट हो गया, ये दूसरा डिजिट हो गया. अभी पुट अ स्लैश. जितने डिजिट यहाँ पर है उतने ही डिजिट के बाद स्लैश लगेगा रिमाइंडर के लिए. ओके, फर्स्ट नंबर एज इट इज 1. You multiply this with 11. So this is 1, 1. 2 plus 1 is 3. Then we have a slash. Multiply by 3. 3 ones are 3. 3 ones are 3. 3 plus 2, 5 plus 1, 6 and 7. So 65, this is your remainder and this is your quotient. I hope this is clear. If suppose you have a larger number, then you have that, check whether 1, 2, 1, 2, 2, it is divisible by 889. So what is this? This is 1, 2, 1, 2, 2. You want to divide by 8, 8, 9. So all from 9, last from 10. This is 8 till. This is divisible by 898. 898. So 10 minus 8 is 2, 9 minus 9 is 0, 9 minus 8 is 1. So this is MD, modified divisor. It has 3 digits. So start from the right, 2, 2, 1. 3 digits, we put a slash here. So first number as it is 1, then multiply by 102 this number. So this is 102. Add 2 plus 1 is 3, right? Then multiply by 3. 3 ones are 3, 3 0, 3 twos are 6. We put a slash. 3 plus 1 is 4, 2 plus 2 is 4. And 6 plus 2 is 4, 8, 48. So this is your quotient and this is your remainder. See how simple is this? इतने बड़े नंबर से आप डिवाइड कर रहे हो, ये कुछ सेकंड्स में ही हो जाता है ऐसे. Shall I erase this? Now, sometimes what you get, that you are getting the remainder more than the divisor. Then how do you manipulate it? Now, for example, you have that you divide 1, 1, 0, 3, 1 by 88. So it is 1, 1, 0, 3, 1. We are dividing by 88. So what is the modified divisor? 10 minus 8 is 2, 9 minus 8 is 1. So we put a slash here. Okay. So we divide first number as it is, then multiply 1 into 1, 1 twos are 2. 1 plus 1 is 2. Then 2 say 2 ones are 2, 2 twos are 4. 2 plus 2 is 4. Okay. We put a slash 4. 4 ones are 4, 4 twos are 8. Now 8 plus 1 is 9. 4 plus 4, 8 plus 3, 11. अब देखो 111, it is more than 88. So this cannot be the remainder. So what we do? Whatever is this number, the leftmost number, we add this to the divisor. So what is this? Sorry, quotient. 124 plus 1. So this becomes 125. So how much is left? 19. What we do? We divide, we multiply this modified divisor with this 1, जो number आपने shift किया है. So 12 ones are 12. इसमें add कर दिया. So this is 31. So this is your quotient and this is your remainder. I hope this is clear. When the remainder is more than the divisor, we adopt this technique. Let me repeat. We were getting 119 as the remainder. It is more than the divisor 88. So what we do, this leftmost digit या जो भी है उसको हम quotient में shift कर देते हैं. यहाँ पर हमने इस 1 को add कर दिया तो 124 plus 1 is 125. और यहाँ पर जो 19 बचा उसमें इसको हम इस modified divisor से multiply करते हैं. तो this is 12. 12 ones are 12. So 19 plus 12 is 31. So this is the remainder. I hope this is clear. Let me give you one more example so that it will be more clear to you. If suppose you have, why we multiply this 12 by remainder? Not by the remainder, we are multiplying this 12 only with the digit which you are shifting. This is the method in Vedic mathematics. For example, if you have say 131, 432, you divide by 899. So what we have, that this is 131, 432, you are dividing by 899. All from 9, last from 10, 10 minus 9 is 1, 9 minus 9 is 0, 9 minus 8 is 1. It has 3 digits, so we put a slash here for the remainder. Now first number as it is, 1 into 1, 0, 1, 3 plus 1 is 4, multiply by 4, 4 ones are 4, 4, 0, 4 ones are 4. So 4 plus 1 is 5. Okay, we put a slash, 5 se multiply karo, 5 ones are 5, 0, 5 ones are 5. Now 5, 4 plus 1 is 10, 5, 4 plus 3 is 7, and 5 plus 2 is 7. Now remainder had 3, but it has 4. So what we do, isko hum yahan shift kar denge. So we have 145 plus 1, this is equal to 146. This is your quotient. What is left? 077. We are shifting the Rajbala last. I did not get your question. So 077, we multiply 101 with this 1 and add 101. So 7 plus 1 is 8, 7, 1. So 178, this is your remainder. Yes. Okay. Shall I erase this? You just try this question quickly, then I will give you another method. Just try this. Divide this by 87. And tell me what is the quotient and remainder. Very good. Dhanya Malhotra, very good. Very good. Anjali. Anjali is giving almost all the answers. Very good. Disha Sharma, good. Yes. So many of the students have answered, means they got the method. Now, next is, there is an importance of the zero also while we derive, and we cannot neglect this zero. What does it mean? So this is basically importance of zero. Now, what is the meaning of this? If suppose you have 1322, you divide by 99. It means this is 1322. Okay. You want to divide by 99. So what is the modified divisor? 1, right? When you subtract, but not, it is 1. We have all from 9, last from 10. So 10 minus 9 is 1, but 10 minus 9 is 1, 9 minus 9 is 0. So we need to put this 0 also. You cannot remove this 0, okay? And it has 2 digits now. Agar 0 nahi lagaoge, ek single digit rahega, to remainder bhi galat ho jayega. So we put a slash here for 2 digits. So first number as it is, then 1 into 0 is 0, 1 into 1 is 1, 3 plus 3, then 3 into 0 and 3 into 3. 3 ones are 3. So this is 3 and 5. So this is your quotient and this is your remainder. Similarly, if suppose you have a larger number, say that you want to divide this 1332 by 999. See what happens. Same number. This is there, right? 999. So what is the modified divisor? This is 001. Please do not remove this 00 here. And it has 3 digits. We put a slash here. So first number as it is, then we multiply. This is 001. So what is, this is 323. This is your quotient and this is your remainder. So you can see this 0 plays very important role. I just explained you the importance of the Veniculum. So how do we use Veniculum in solving the questions? This is my next task. Shall I erase this? So if suppose you have a number 231873, you divide by 9818. Now here you can, I will solve this question using 4 methods in front of you, and you will surprised to know that you will get all answers same. So first is that we have, this is normal method, which I just explained you, 873, and this is 9818. What is the modified divisor? 10 minus 8 is 2, 9 minus 1 is 8, 9 minus 8 is 1, 9 minus 0. So we put a 0. It has 4 digits, we put a slash here. So first number as it is 2, then we multiply 202, 2 ones are 2, 2 8s are 16. Okay, 2 2s are 4. 3 plus 0 is 3, we put a slash. Now 3 into 0 is 0, 3 ones are 3, 3 8s are 24, 3 2s are 6. Add 2 plus 3, 1 is 3, right? 16 plus 3, 19. 19 plus 8, kitna aayega? 27. Then 24 plus 4, 28 plus 7, 35 and 9. See, it has 2, 4, 6 digits, but we want only 4 digits in the remainder. So what we do, we keep on adding. I mean, these are the carryovers. First is 9, then this is 5, 27 plus 3. Isko yahan le aao. This is 30, then 3. 3 plus 3 is 6. So this is your quotient. This is your remainder. This is first method. But if you see that here in the divisor as well as the dividend, we have digits more than or equal to 5. So what we do, that we can take its Veniculum. This is second method. So what we do, that we have this 231873. So we want to divide by 9818. Its modified divisor is 182. See, because of this 8, we are getting here double digits. Okay, we want to get rid of these double digits. So what we take? We take here the Veniculum of this modified divisors. Modified divisors ye hai, iska Veniculum nikalo. So how do we find? This 2 is less than 5. जो भी digits 5 और 5 से बड़े होंगे उनका निकालेंगे. तो 2 तो छोटा है, इसको as it is. 10 minus 8 is 2. So we put a bar and add 1 to this. This is 2. Okay. And we put a 0 here. So this is the new modified divisors. Because of this new modified divisors, we will get rid of these double terms. How? And we put a slash because it has a 4 digit. So we put a slash here. So first number as it is, this is 2. We multiply by 2. So 2, 0, 2. 2 2s are 4. 2 2s are 4 bar. And 2 2s are 4. 3 plus 0 is 3. Then we multiply by 3. 3 into 0. 3 2s are 6. 3 2s are 6 bar. 3 2s are 6. We stop and we calculate. 6 plus 3 is 9. 7 plus 4, 11. 11 minus 6 is 5. Then 8 plus 6, 14. 14 minus 4 is 10. So we write 10 like this because it is carryover. 4 plus 1 is 5. But in this 5, we add this one. So this is 6059. This is your remainder and this is your quotient. You can see in the previous also we are getting the same thing. This is second method. Third method, have you noted down so that I can move forward? Any doubt? Okay, so in the dividend also we are getting digits more than or equal to 5. So we can take the veniculum of this number. So see, this is 2, 3, 2, 3, 1, 8, 7, 3. So these numbers, these are sometime question. Asta, I'm not getting your point. Sometimes these numbers are more than or more than 5. So we find the veniculum. So 3 is number less than. In answer, see in answer we have 4 digits, but here we have 5 digits. So whenever we have double digits, this was 10. So obviously we write 0 here and we add this one to the next one. If the total number are 4 equal to the number of digits here in the remainder, then there is no problem. We'll leave it as it is. So see, this 2, 3, 1, 8, 7, 3, we find veniculum. So 10 minus 7 is 3 bar. 9 minus 8 is 1 bar. We add 1 to this. This is 2, 3, 2. So this is the veniculum of this number. We will use this now in the next. So we have the same question, but here we take the veniculum. So veniculum is 2, 3, 2, 1 bar, 3 bar, and 3. We want to divide it by 9818. Its modified divisor is 182. Okay. And we have 4 digits. We put a slash here. Now we keep on. First number as it is. We multiply this by this. So 2, 0, 2 1s are 2, 2 8s are 16, and 2 2s are 4. So 3 plus 0 is 3. Again we multiply. 3 into 0, 3 1s are 3, 3 8s are 24, 3 2s are 6. 3 2s are 6. Add 3 plus 6, 9. 24 plus 4, 28. 28 minus 3 is 25. So we write 25. Then 16 plus 3, 19 minus 8. 19 minus 8. 19 minus 1, sorry, 9 minus 1 is 18. Then 2 plus 2 is 4. Now, how do we write the answer? Because here we have 4 digits only in the remainder. यहाँ पर 4 ही है, पर यहाँ पर 6 आ गए, तो हमें कम करने पड़ेंगी. This is 9, 5. 18 plus 2 is 20, 0. Then 4 plus 2 is 6. You can see, this is quotient, this is remainder. हर बार यही आ रहा remainder. अब problem क्या है कि यहाँ फिर से डबल डिजिट आ गए. 16 and 24, ये डबल डिजिट, हमें इनसे भी छुटकारा चाहिए. तो हम क्या करेंगे? This is the veniculum of the number dividend, and here we have 9818. Its modified divisor is 0182, and we take its new modified divisor, means we take its veniculum. So this is 0 to 2 bar as we have done in this question. Now let us see, इससे भी होता नहीं होता. We put a slash here. First number as it is 2, then we multiply this with this. So what is this? This is 0. 2 2s are 4, 2 2s are 4 bar, 2 2s are 4. So 3 plus 0 is 3. Then so we have 3. 3 into 0 is 3. 3 2s are 6. 3 2s are 6 bar. 3 2s are 6. Let us add 4 2s are 6. 6, 4 bar. 4 plus 1 is 5. 6 minus 5 is 1. Then you see, this is 6 plus 3. This thing is 3 bar plus 6 bar plus 4. Means 6 plus 3, 9 bar. Minus 9 plus 4, it is 5 bar. 5 bar. 6 plus 3 is 9. Now we have to convert this into the normal number because this is Veniculum. So what happens? This is 9. 10 minus 5 is 5. And we subtract 1 from here. This is 0 and 6. So this is quotient. This is remainder. So in front of you, I solved same question using 4 methods. Okay. So you can adopt any one of them as per your convenience. Now, how do we check the answer? Right? And second thing is that if you want a number in decimals, how do we proceed? ये तो आपने रिमाइंडर के साथ निकाला है ना. अगर आपको डेसिमल में निकालना है तो फिर क्या करें? Okay. Shall I erase this? First thing is that if you want to check the answer, we had that when you have, you are dividing, same question later, that you are dividing 2, 3, 1, 8, 7, 3. When you divide this 9, 8, 9, this, the remainder quotient is coming out to be 23 and remainder is coming out to be 6059. You just saw. I think you know the Euclidean remainder that we have, that dividend is equal to divisor into quotient plus remainder. So here we have 231873. This is 9818 multiplied by 23 and plus 6059. We have the situation. So what we do, we find out cross digit sum of each and under the same operation. So what does it mean? If you find out the cross digit sum of this, 8 plus 1 is 9, we cross. Okay. 7 plus 2, 9, we cross. So what is this? 3 plus 3 is 6. So 6 is the single digit sum of this. Come to this, 9 cancel, 8 plus 1, 9 cancel. So it is 8 only. We multiply this with 3 plus 2 is 5. Multiply. Then plus 609 cancel, 6 plus 5 is 11. 6 plus 5, 11. 11 plus 1 is 1 plus 1 is 2. So we write 2. If you simplify this, 8 5s are 40. 40 plus 2. This is 42. 42 means 4 plus 2 is 6. You can see both are matching. It means the answer is correct. In this way, we can find out, we can check our answer in case of division. Any doubt? Now, after finishing this, the Parvata method, please repeat. Okay. See, I just did this question. I did this question. So here quotient is 23, remainder is 6059. And you know, this equation is satisfied in case of dividend and divisor. The dividend is obtained by multiplying quotient with divisor and adding remainder. So I just put all the values. यहाँ जो भी values आई थी वो मैंने इसमें रख दी और इनका single digit sum निकाल लिया. Single digit sum क्या होता है कि जब आप कहीं भी 9 दिखता है आपको 9, 8 plus 1 9, इनको काट दो, 7 plus 2 9, उनको भी काट दो. जो बाकी वाले नंबर हैं, जो बाकी बचे नंबर है 3 और 3, ये 6. तो ये 6 आ गया इसका सिंगल डिजिट सम। या आप इन सारे नंबर्स को ऐड भी कर सकते हो, मतलब 2 + 3 + 1 + 8 + 7 + 3, ये भी आपको वही आएगा, पर हमें टाइम सेव करना है, इसलिए मैं वो 8 प्लस जहां भी 9 आता है उसको काट देते हैं। जैसे आप इसको भी ऐड करोगे, 7 + 3 10 + 18 + 1 19 + 3 22 + 24 24 2 4 + 4 is 6। या तो आप ऐसे कर लो, या आप जो भी 9 बनता है, जहां भी 9 2 डिजिट्स का 3 डिजिट्स का सम 9 बनता है उनको काट दो। तो इसलिए मैंने किया 8 + 1 9, इसको काट दिया, 7 + 2 9, इसको काट दिया, तो बचे 3 and 3 3 + 3 6 कम हियर, 9 काट दिया, 8 + 1 is 9, इसको भी काट दिया, 8 बचा तो 8 लिख लिया। अब ये क्या है, दिस इज मल्टीप्लाइड विद 23, 2 + 3 is 5, तो 2 + 3 is 5, यहाँ पर 9 कट गया, 6 + 5 is 11, 11 means 1 + 1 is 2, तो ये 2 आ गया। नाउ आपको ऑपरेशन सेम ही लगाना है, यहाँ मल्टीप्लाई था तो मल्टीप्लाई करना है, यहाँ पर एडिशन था तो एडिशन ही करना है, सेम ऑपरेशन। So 8 + 5 is 40, 40 आ गया, +2, so this 40 + 2 is 42, 42 means 4 + 2 is 6। अब ये मैच कर रहे हैं 6 और 6, इसका मतलब आंसर करेक्ट है। तो इस तरह हम डिवीजन में आंसर चेक कर सकते हैं। आई होप दिस इज क्लियर नाउ। Okay, this is Pervading method. If you have observed here, I did all the questions where the number, the divisors, they are less than the base. Means it was 889, 87, 88, 92, like this. So all the numbers are less than the base. But if the numbers are more than base, how do we perform? If the numbers are more than base, then obviously we have modified divisor in terms of the negative numbers. For example, you have 113. If you subtract it from 100, so what you are getting? -13. So we need to write modified divisors as 1 bar, 3 bar. So this is known as Pervading method, because पर्वत का मतलब है ऊंचाई पर उठा हुआ, तो इसमें उठा हुआ कितना है, 13 नंबर से उठा हुआ है, बेस से ज्यादा। So that is why we use this Pervading method and we write the modified divisor in terms of the Veniculum. So if for example you have that you divide 1247 and you divide this by 113, this is known as Pervading method. So we have 1247. We want to divide it by 113. So as I explained you, it is 1 bar, 3 bar. This is your modified divisors, MD. So it has 2 digits. We put a slash here. So first number as it is 1. We multiply this by 13, 1 bar, 3 bar. So 1 bar, and this is 3 bar. 2 minus 1, 2 minus 1 is 1, because it is 2. It is 2 plus 1 bar, which is same as 2 minus 1, which is 1. So 1, we put slash, again multiply. This is 1 bar, 3 bar. Now this is 4, 3 bar, 1 bar is 4 bar. 4 minus 4 is 0. 7 minus 3 bar is 4. So this is your quotient. This is your remainder. Okay. Now, if for example you have that 1 3, this is 1 3 6 2 1, you divide by 123. So if this is the question, because time is less, I just want to explain, if you are getting all the digits in the remainder in with bar or negative numbers, so what happens? So this is 1 3 6 2 1. We want to divide by 123. So if you subtract from 100, you get 2 bar, 3 bar. This is your modified divisors. It has 2 digits, so we put a slash here. So first number as it is 1 into this, so this is 2 bar and 3 bar. 3 minus 2 is 1. Again 1 into 2 bar and then 3 bar. 6 minus 3 bar, 2 bar is 5 bar. 6 minus 5 is 1. So this is 1. We put a slash. Again 1 into 2, 2 bar and 3 bar. 3 bar minus 1 is 2 bar. 3 bar 2 bar, 5 bar, 5 bar minus 5 bar plus 2. It means this is 3 bar. So in the remainder, you are getting all digits as bar with bar. So this is your quotient. And this is 3 bar is basically minus 32. So what we do? We will subtract this 32 from this divisor, means from 123. And we subtract 1 from the quotient. So this is 110. And what is this? 3 minus 2 is 1. 12 minus 3 is 91. So we have, this is, quotient is this, and this is your remainder. What happens to this? Sorry. So in that case, 110 was the quotient and remainder was 91. Okay. Let me do one more question. So if suppose you have that you divide 23713 by 112. So this is 23713 divide by 112. So modified divisor is 1 bar, 2 bar. We put a slash here. First number as it is, then 2 ones are 2, 2 twos are 4. 3 minus 2 is 1, then 1 bar, and then this is 2 bar. Then this is 7 minus 5 is 2. We put a slash. Then 2 ones are 2, and 2 twos are 4. So 2 bar, 2 bar, 4 bar, and this is 3 bar. 4 minus 3, it is 1 bar. Both are with bar. So what we do, we subtract 1 from the quotient. So this is 211. And we subtract this from the divisor, 112 minus 31. So 3 minus 2 minus 1 is 1. 11 minus 3 is 9. 11 minus 3 is 8. So this is your quotient and this is your remainder. So in this way we solve. Okay. Now, I want to explain you one more thing here. There are so many things in the divisor, but because of paucity of time, I won't be able to take more methods. There are so many other methods also which are used, but these are the simpler one. You can also divide using the same type of method when you want to divide one polynomial by another polynomial, one algebraic equation by another algebraic equation, algebraic expression. But along with this, I want to tell you one thing, very interesting thing. I think you know the astronomy, astrology, and the names and the fate numbers. I just explained you the cross digit sum. Okay. This is very interesting thing which I want to explain you. See, if suppose your date of birth is anything, say if I say this is your date of birth is 28, say 6 June 1995, for example. So what we do, that we just cross all nines. There is no other 9, 9, 9, 8 plus 1, 9. This also goes. Okay. So what is left? 6 plus 2, 8 plus 5, 13. Right? This 8 plus 5, 13. This is also 4. This 4, this is known as your fate number. Fate number means your life is governed by this fate number. But sometimes you must have seen that people used to add some alphabet into their names. अपने नाम में एक एक्स्ट्रा अल्फाबेट जोड़ लेते हैं ना, मतलब पंडित जी कहते हैं कि आपका नाम आपके हिसाब से नहीं है, आप एक ए ऐड कर दो या कुछ ओ ऐड कर दो, कुछ और ऐड कर दो, तो आपके सारे काम बन जाएंगे. So what is the logic behind? Actually, we have a number name also. So how do we calculate your number name? If your fate number and your number name, they are complement of each other, means the total is 9, then it is very good. It means that whatever effort you made in getting your goal, and in getting your goal, then 100% you will get success, right? Otherwise, you will have to face problems in that. How do we find this? So, for example, my name is Anuradha. I want to calculate my name, my number, name number. So this is, I think, okay. All of you try to find out your fate number by the time I explain you. Since we count up to 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. I just want to calculate fate number again. Okay. I will explain first. Let me write this, then I will explain. And these are the alphabets which are used in your name. Right? Now, if you are writing your surname, I mean, in your certificates, the surname is there, you use that. If it is not there, don't use, because that you are known by that name. For example, I use Anuradha Gupta. I now write the corresponding number. Say A stands for 1. A के सामने 1 है, तो A1. N यहाँ पर है, इसके सामने 5 है. So we write 5. U is 3. R is 9. A is 1. D is 4. H is 8. And A is again 1. And I just add. And here also G. G stands for 7. U stands for 3. P is 7. T is 2. And A is 1. Again, we cross 9 goes, 8 plus 1, 9 goes, 5 plus 4 goes, 3 plus 4, 3, 4, 5. 5 ho gaya. Same way here, 7 plus 2, 9 goes. Then 7 plus 3, 10 plus 1, 11. And this is 2 plus 2. So this is 7. This 7 is my name number. Okay. And if suppose my date of birth is fate number is 2, then 7 plus 2 is 9. It is very, very good. So if suppose they are not getting, if 7 plus 2, this is 7, and if I'm getting fate number as 1, obviously what I do that I can add one A here. So it becomes 8. 8 plus 1 is 9. So this is the way people used to add alphabets in their name just to make it the perfect square, perfect number. So somebody was asking how to find out the date of birth or fate number. So it is, I just explained you that if suppose your date of birth is 18th July 1996, you just cross 9 there, then 8 plus 1, 9, this goes. So whatever is left, 6 plus 1, 7, and 7. So this is 14. 14 is 1 plus, so fate number is 5. In this way we calculate the birth or fate number. Okay. Fate number, the date of this name number and fate number, they should be complement to each other. The sum should be 9. Then it is very good for you. Then it is easier for you to achieve your goals. Now 6 minutes are left. If you want, I can give you one more question on, let me give you exercise. Please note down the exercise on division so that you can try. So this is using Veniculum or Dvajank. This is, write down the exercise 2120598. If they are not matching, they have different significance. But in this class, I cannot take all because it depends on the numerology. There are several other factors also. This is 12343 divided by 979. Please note down this exercise for practice. You can use here Veniculum method because all numbers are less than the base. For Pervading method also, let me give you exercise. One 595 divide this by 202. 4348 we divide by 303 and 11288 you divide by 605. You can try these questions. See this divisibility, this is a long article and we have so many methods in this division, but I was able to do only 3. Okay, so some other time, if I will get some other day the opportunity, definitely I will try to explain the remaining methods. Thank you so much. Thank you so much for cooperation, and also thank Ignou Bhiwani for giving me the opportunity to interact with the students as well as the faculty members. Thank you so much. Over to you, Kruti ma'am.
Thank you, madam. Thank you. Is there any question? Then you can ask me, please. Ma'am, there are number of messages in inbox. If you see, there is a number of comments for your appreciation. One comment is there. Hats to you, ma'am. A wonderful presentation, ma'am.
Thank you so much.
Thank you, madam. Thank you, madam. Number of comments are there, ma'am.
Thank you so much.
आप वाकई एक अद्भुत टीचर हैं मैम। आपने एक आश्चर्यजनक तरीके से अपने आप स्टूडेंट्स को जो भी कैंडिडेट्स हैं उनको अट्रैक्ट कर लिया। मैडम प्रूथी कुछ बोलना चाहेंगी आप? अगर मैं आवाज सुन रहा हूँ।
हाँ बिल्कुल। बहुत अच्छा लगा मैम से सुन के, और मैम इतना 2 घंटे तक लगातार बोलना रियली बहुत ही अप्रिशिएट करते हैं मैम कि आपने इतना आराम से समझाया सबको, और सब बच्चों ने बहुत अप्रिशिएट किया है, एक्टिवली पार्टिसिपेट किया है। Thank you ma'am for your this presentation and the nice knowledge we have got from this presentation. Thank you ma'am, and we like to invite you in our institution.
जी
थैंक यू सो मच। ये ना अब आज डिविजिबिलिटी पूरा हो नहीं पाया क्योंकि ये कम से कम भी 7 से 8 घंटे का है। ये शायद 1/4 भी नहीं हो पाया आज, क्योंकि 2 घंटे में ये नहीं हो पाता। तो जितना मैंने कोशिश किया, जो सिंपल मेथड थे जिससे एटलीस्ट इनका डिविजिबिलिटी वाला काम चल जाए, उतना मैंने करवा दिया है।
अरे वाह, एक हिंदी में वर्ड होता है मैडम जो सब कुछ कवर कर लेता है, उसको हम बोलते हैं मैडम गजब। आपने गजब कर दिया मैडम आज। जय के नीचे छोटी सी बिंदी भी होती है, उसमें गजब। मैडम मैं पूछ सकता हूँ आप लोगों से एक बात?
हाँ जी बताइए।
मैडम इतना एनर्जी को मेंटेन करने के लिए क्या डाइट प्लान है आपका? आपकी गजब की एनर्जी है मैडम। कोई भी फील्ड आपने अछुआ छोड़ा ही नहीं है। आप रिसर्चर एज वेल एज मोटिवेटर एज वेल एज कन्वीनर ऑफ नंबर ऑफ वर्कशॉप लेक्चर्स। मैडम कमाल है मैडम, हैट्स टू यू। थैंक यू मैडम, आपने हमारे आईजी यूनिवर्सिटी की वर्कशॉप में आपने 4 चांद लगा दिए मैडम।
आपने सुबह मॉर्निंग में सब लोगों की इतनी तारीफ की थी ना कि उनका लेक्चर ऐसा हुआ ऐसा हुआ, तो मैं सच में डर गई थी कि पता नहीं मैं
नहीं मैडम, हमने तो ये सोचा था मैडम कि वैदिक मैथमेटिक्स अब शायद खत्म होने लग रहा है, लेकिन आपने तो बताया कि वैदिक की तो भी शुरुआत हो रही है।
बिल्कुल शुरुआत हो रही है। हम तो
मैडम और हमारे यहाँ पे सिर्फ आईजी यूनिवर्सिटी के ही स्टूडेंट्स नहीं हैं, चारों तरफ की यूनिवर्सिटी से भी लोग जुड़े हुए हैं, कॉलेजेस से भी जुड़े हुए हैं। सब लोग एक दूसरे को लाइक करते हैं। और वैदिक मैथमेटिक्स में ना बहुत ज्यादा काम लग रहा है, बहुत कुछ है सीखने के लिए अभी भी।
बिल्कुल, बहुत
और
कुछ है, बहुत रिसर्च हो रही है,
आप
हम उसी डायरेक्शन में
आप
काम कर
जैसे आप जैसे लोगों के सहयोग से, मोटिवेशन से कोई ना कोई हमारा रिसर्च स्कॉलर, हम खुद जरूर इसको अग्रसर लेते हैं मैडम। और जैसे ही कोविड की रेस्ट्रिक्शन हटती हैं तो जैसा मैडम बता रही थी, आपको जरूर इनवाइट करेंगे मैडम, आपको
हैं।
हमारे डिपार्टमेंट में आना मैडम।
ये अभी एक बच्चे ने पूछा कि आपने पीएचडी की हुई है? हाँ, मैंने पीएचडी
अरे
तो की है।
वाह, अरे वाह, ये मैंने सबसे पहले ही बताया। मैंने आपने शायद ये बच्चे ने ज्वाइन नहीं किया होगा जिसने भी पूछा है
मैंने
मैडम।
की है, और उसके अलावा
मैथ्स
10 स्टूडेंट्स को मैं पीएचडी करवा चुकी हूँ, और 6 और मेरे साथ काम कर रहे हैं।
वेरी गुड। मैडम ने मैथमेटिक्स ऑनर्स कर रखा है 1986 में, और मैडम ने उसके बाद एमए, एमफिल, पीएचडी तो 1999 में कंप्लीट कर लिया है। और अभी
हाँ,
मैडम ने जैसा बताया कि आप 10 स्टूडेंट्स से ज्यादा स्टूडेंट्स को पीएचडी करा चुके हैं, और अभी भी 7-8 को पीएचडी करा रहे हैं। मैडम ये सब तारीफ के काबिल है। भगवान ऐसा करे आप यूं ही काम करते रहें, और पूरी बड़ी टीम बनाए मैडम आप, और उस टीम में हमको भी जोड़ लो मैडम, कहीं ना कहीं काम आएंगे मैडम।
बिल्कुल। आप, मुझे लगता है आप लोगों को ज्यादा एक्सपीरियंस होगा, मुझे नहीं होगा इतना, मुझे तो आप लोगों से बहुत कुछ सीखना है।
जी मैडम, थैंक यू मैडम, थैंक यू
चल आई लीव?
मैडम। मैडम मंजू प्रूथी, प्लीज अलाउ करें कि मीटिंग को ऑफ कर दिया जाए।
हाँ हाँ बिल्कुल मैम, आपसे मिलकर बहुत अच्छा लगा, आपका एक्सपीरियंस देख के, आपका काम देख के, तो आगे भी मौका मिलता रहना चाहिए आपसे बात करने का। थैंक यू मैम, अगेन थैंक यू फॉर coming in this virtual meeting and giving this knowledge. Thank you ma'am.
Thank you so much. Shall I end the
Dr. Bharat, thank you to all
जी मैम,
the
प्रतिभा का भी थैंक यू
participants
बोल दिया करो मैडम।
and
कभी कभी प्रतिभा मैडम
हाँ
लगी हुई है
प्रतिभा
दिन
तो
रात।
मैं यहाँ, वो मेरे साथ ही रहती है तो मैं उसको बोल देती हूँ।
जी
प्रतिभा
थैंक यू
बहुत
मैम।
मेहनत कर रही है अभी गूगल फॉर्म्स
थैंक यू
बनाना।
मैम।
और मेरे
ओके
पास
प्रतिभा,
काफी
थैंक
लंबी
यू,
लिस्ट है मैडम
थैंक यू
अपने
टू ऑल ऑफ
कोलीग्स
यू
की।
एंड वी विल मीट।
जी
टीचर्स भी इसमें अटेंड कर रहे हैं कुछ?
जी मैडम, टीचर अलग अलग
हाँ
कॉलेजेस से
टीचर्स
हैं,
भी है
जैसे
मैम इसमें यार, कॉलेज।
फरीदाबाद से ज्वाइन किए हुए मैडम डॉक्टर धर्मवीर वशिष्ठ हैं, डॉक्टर सतबीर जी हैं, एसोसिएट प्रोफेसर हैं। वो कल मैं एक अच्छी सी लिस्ट बनाऊंगा प्रॉपर तरीके से सभी की, और फिर मैं उनके नाम बताऊंगा। शायद कल आप वैलिडिटी में रहेंगे मैडम, हम आपसे रिक्वेस्ट कर रहे हैं। ये
लिंक सेम रहेगा उसका?
हाँ, लिंक सेम ही रहेगा मैडम, लिंक
हाँ
सेम
जी
ही रहेगा।
मैम।
ठीक है,
जी
मैं
मैडम,
करूंगी। और दूसरा,
ओके।
जो वो वैदिक गणित पढ़ाते हैं आपके यहाँ, उनको आज का लेक्चर कैसा लगा मैं जानना चाहूंगी, क्योंकि
अरे
वो तो
अरे खुराना साहब, एक्चुअली मैडम मैं वैदिक मैथमेटिक्स, हमने एक पेपर डाला था 100 नंबर का, पूरा पेपर। उस टाइम पे राकेश भाटिया जी पढ़ाते थे। खुराना
नहीं,
साहब आप हैं प्लीज?
बिल्कुल बिल्कुल डॉक्टर साहब।
अरे मैडम, मैडम आपसे जानना चाह रही हैं व्हाट अबाउट द टुडे लेक्चर्स, प्लीज गिव द फीडबैक।
बहुत अच्छा लगा मैडम, वेरी इंटरेस्टिंग।
अरे फैट नंबर निकालना खुराना साहब आपने हमें नहीं सिखाया था, मैडम ने आज फैट नंबर निकालना भी सिखाया, देखो डेट ऑफ बर्थ के साथ।
ये ना, अभी इस पे पूरी इस पे जो है न्यूमरोलॉजी पे मैंने लेक्चर तैयार किया हुआ है, जिसमें हम बताते हैं कि अगर आपका ये नंबर आता है तो आपकी लाइफ पे क्या इम्पैक्ट होता है, पर वो अभी टाइम नहीं
अरे
था
वाह,
ना।
अरे वाह, ये तो मैडम गजब की चीज निकाल रखी है आप लोगों ने मैडम।
हम लोग खाली हमारे ऋषि मुनियों ने किया हुआ है, हम तो सिर्फ थोड़ा
अरे
पढ़ के आप लोगों को बता देते हैं थोड़ा बहुत।
अरे
हमने तो
वाह, अरे वाह, वाकई तारीफे काबिल है मैडम,
देखो
बहुत बढ़िया।
डॉक्टर बड़क, डॉक्टर रीटा ने मैसेज कर रखा है कि वो हमारे साथ करनाल से जुड़ी हुई हैं। तो अच्छा, वेलकम मैम कि आपने इतनी दूर से हमारे यूनिवर्सिटी को चॉइस किया और अटेंड किया।
हाँ मैडम, इनका नाम मैं लिस्ट बनाऊंगा मैडम, कोई छूट ना जाए इसलिए। डॉक्टर रीना फ्रॉम गवर्नमेंट कॉलेज मत्तक माजरी, इंदिरा करनाल, मटक माजरी, सॉरी। हाँ मैडम, थैंक यू मैडम। डॉक्टर रीना आपने ज्वाइन किया, और बाकी सब नाम जो भी आएंगे हमारे पास सभी को मैं जरूर लूंगा। वैलिडिटी फंक्शन में हम ये काम करने वाले हैं। तो मैडम मीटिंग को ऑफ कर दिया जाए मैडम?
हाँ जी बिल्कुल करिए।
ओके मैडम थैंक यू
बिल्कुल
मैडम।
डॉक्टर बड़क, थैंक यू।
Thank you.
ओके डॉक्टर अनुराधा जी,
Thank you so much. Thank you all of you. नमस्कार।
ओके
थैंक यू वेरी मच मैडम।
हाँ जी बिल्कुल कोशिश करूंगी। ठीक है, थैंक यू।